Welcome to The Explainer. Today we're going to pull back the curtain on one of the most powerful and widespread programming languages on the entire planet, Java. So let's just dive right in and see what makes it such a titan of technology.
Okay, to really get a sense of the scale we're talking about, let's start with this number. There are an estimated 9 million Java developers in the world. That is a massive global community of talent building and maintaining the digital world that we all live in.
So what are all these developers actually doing? Well, they're building the digital infrastructure we rely on every single day. We're talking about the huge enterprise software that runs banks and businesses, the big data tools like Spark and Hadoop that are literally shaping our future, and yeah, even the Android apps right there on your phone. Java is absolutely everywhere.
But here's the wild part. This global standard, this language that powers the internet, it didn't even start with the internet in mind. Nope. Its journey began way back in 1991 with a project at Sun Microsystems for a totally different technology, interactive television. It was an idea that was way ahead of its time.
So how in the world did Java make the leap from a niche interactive TV project to basically conquering the digital world? Well, it all comes down to a single revolutionary idea. The goal was, simple on the surface, but incredibly ambitious. As this quote says, it was all about portability and security. Now, you have to remember, back in the 90s, this was a huge deal. Software was completely tied to the specific hardware it ran on. The team wanted to build something that would let you write code one time and have it run on any device, anywhere, without having to rewrite it.
And this is exactly how they pulled it off. It was this genius three-step process. First, developers write their code. Then, a compiler turns that code into this neutral, middleman format called bytecode. You can think of it like a universal blueprint for computers. And then step 3, that single bytecode file can be run on any machine. This became the famous promise, write once, run anywhere.
And the secret sauce, the absolute magic behind this whole system, is the JVM, the Java Virtual Machine. It's like having a universal translator built right into every single device. As long as a device has a JVM, it can take that universal bytecode and translate it into the specific instructions its own hardware can understand. That's what made Java so incredibly powerful.
And hey, here's a little bit of trivia for you. The project, which was led by James Gosling and his green team, was originally called Oak, chosen as a symbol of strength. But when they found out that name was already trademarked, they had to pivot. So in 1995, they renamed it Java, inspired by all the coffee they were drinking while working on it.
So with this incredibly powerful foundation of portability, Java didn't just survive, it absolutely thrived. It grew into this massive, self-sustaining ecosystem. Let's take a quick look at how this universe just kept expanding over the years.
Its core features really made it the perfect choice for serious, heavy-duty applications. It was object-oriented, which basically means it's easier to organize and manage huge projects. It was robust, with things like automatic memory management that prevented a lot of common programming errors. It was secure from the ground up, and thanks to something called a just-in-time compiler, it was also surprisingly fast.
And the thing is, Java never stopped evolving. It never got complacent. I mean, look at this timeline. From its first release back in '96 to Java 8 in 2014, which brought in modern features like lambdas that make code so much cleaner, all the way up to Java 21, which introduced virtual threads, a feature that makes Java incredibly efficient for the huge, massive scale applications we see in the cloud today. It has constantly reinvented itself to stay on top.
Now, all this constant innovation fueled an enormous ecosystem of frameworks. You've probably heard of some of these names, like Spring or Hibernate. These are basically powerful toolkits that give developers pre-written code for common tasks, which lets them build really complex and reliable applications way faster than if they had to start from scratch. And that ecosystem was supported by a world-class suite of tools for every single part of the process, from building projects with Maven and Gradle to testing with JUnit. This rich toolkit is a huge reason why so many developers just love working with Java.
So after 3 decades, you might be thinking, is Java's story finally coming to an end? Is it a legacy language now? Well, all the evidence suggests not even close. In fact, its next generation is already taking shape.
First up is Project Loom, and this is a true game changer. It introduces these super lightweight virtual threads. The best way to think about it is like a highway with millions of tiny, fast-moving cars, instead of just a few big, slow trucks. This is going to completely revolutionize how Java handles millions of tasks at once, making it perfect for the massive applications that power the modern web.
Then there's Project Valhalla,
And this one is all about supercharging performance. It's basically re-engineering how Java handles data in its memory to make it way more efficient. The bottom line, a massive speed boost for apps that crunch a ton of data, all while using way less memory.
And finally, there's Project Amber, which is all about making life better for the developer. It's focused on adding new language features that let developers say goodbye to all that repetitive, boilerplate code that they hate writing. It just makes them more productive and their code so much cleaner and easier to read.
So when you put all of this together, you see Java isn't just holding its ground. It's pushing into brand new frontiers. It's already a dominant force in the cloud, it's the hidden superpower behind the whole AI and big data revolution, and its legendary stability makes it a really strong candidate for the kind of mission-critical software we're going to need in the coming age of quantum computing.
And so, as we look back on Java's incredible journey, from a wild idea for interactive TV all the way to the edge of the quantum age, it really begs the question, for a language that has already shaped so much of our digital world, could its greatest chapter still be unwritten?